Chapter 1a Numericals. Here we are going to deal with the numericals of moment of force. Moment of force is force into perpendicular distance. Another name of moment of force we used to say torque. So we will write the symbol tau for torque. Question number 1. The moment of force of 10 Newton about a fixed point O is 5 Newton meter. So from the SI unit, from the unit given for the physical quantity, you can identify whether it is force or moment of force. So SI unit of force is Newton, SI unit of moment of force is Newton meter. So here you can see force is given 10 Newton and moment of force or torque is given 5 Newton meter. We are asked to find distance. We have the formula torque is equal to force into distance. From here distance is equal to torque by force. 5 by 10, you will get the answer 0.5 meter. Question number 2. A nut is opened by a wrench of length 10 centimeter. Length or distance is given 10 centimeter. It is not the SI unit. So we should convert it to meter, 0.1 meter. If the least force required is 5 Newton. So force is given 5 Newton. Find the moment of force. Torque is equal to force into distance. 5 into 0.1. We will get the answer 0.5 Newton meter. Question number 3. In this question you can see a small circle. Figure number 1.28. Here 2 points A and B are given and a force 2 Newton is given and O is the center of the circle. Okay, O is the center. We are going to apply force at the top portion. A wheel of diameter 2 meter. So distance or length is given 2 meter is shown in figure with axle at O. That is center at O. A force 2 Newton. Force is given 2 Newton is applied in the direction as shown in figure. Calculate the moment of force about the center. So here you can see torque about center. Force into distance, that is 2 into 1. Why I took here 1? Here the question is moment of force about the center O. So only half distance. The full diameter is 2. So towards the center O, it is only half. Center is O. So instead of taking 2 meter, we have to take 1 meter because first question is about O. Half the distance only we need to take. So here torque about center is force into distance. 2 into 1 you will get 2 Newton meter and it will turn clockwise. You can see the direction to which direction it is about to rotate. It is clockwise direction. Second sub question is calculate the moment of force about the point A. Point A is at the extreme end. From here to A, that is the full length we have to take. So we can take force into distance, that is 2 into 2. You will get 4 Newton meter clockwise. Next question number 4. Here you can see the figure. It is the pivoted point. That is the joining point. And this length is given 2 meter. Here the force is 5 Newton. This side length is 4 meter. Force is 3 Newton. And here you can see here the force is acting downward. That means this side it is going downward like this. That is it is having anti-clockwise movement. And this side it is having clockwise movement. That concept you should keep in mind when you see this diagram. Diagram shows two forces F1 5 Newton and F2 3 Newton acting at the point A and B of a rod pivoted at the point O such that OA is 2 meter and OB is 4 meter. Calculate the torque or moment of force F1 about O. So this is F1. F1 about O, that is force into distance. 5 into 2 you will get 10 Newton meter. As I told, it is having this 10 Newton meter is having anti-clockwise. So sorry, I wrote here clockwise. The first one is anti-clockwise, turn in this side. It is anti-clockwise. So we got it is 10 Newton meter anti-clockwise. Second one F2 about O. This is F2. F2 about O, 4 into 3, 12 Newton meter. It is about to turn clockwise. Okay. So finally what will happen? The question is Find the resultant moment. Find the resultant moment. Since for finding resultant moment, one is clockwise, anti-clock, and another is clockwise, we have to subtract. So 12 minus 10 we will get 2 Newton meter. And which one is more torque, clockwise or anti-clockwise? Obviously you can see clockwise moment is more. So answer will be also, the object will also turn clockwise. So the resultant moment is 2 Newton meter clockwise. Next, question number 5. Here also you can see midpoint O, here one point A, point B. The total length is given 4 meter. And here you can see the force applied here is in upward direction. That means it is about to rotate clockwise. And here is downward direction. So upward and downward doesn't mean two different directions. Actually it is about to rotate clockwise. Both sides it is clockwise. Since it is moving in the same direction and we have the same force, we are asked to calculate the torque, determine the magnitude of resultant moment of force about the pivoted point O. So we can use either force into perpendicular distance, either force, any of the force. 10 into perpendicular distance is 4. So directly we can write torque is equal to force into distance, 4 into 10, 40 Newton meter. It is going to rotate in the clockwise direction. So it is 40 Newton meter towards clockwise direction. Question number 6. Here you can see this O is the midpoint, one point A. Here the point A, the force is 10 Newton, and the point B, it is also 10 Newton. It is upward, it is downward. So you can know it is upward means it is about to rotate clockwise. So both forces, since it is opposite direction, so it is going to rotate in the clockwise. Both A and B is clockwise. And the distance between A and B is given 50 centimeter. Converting to meter, we will get 0.5 meter. Our first question is calculate the torque about the point A by two forces. Here they are clearly mentioning calculate the resultant moment of two forces. You can see in the question here the TWO2 is written in italics. That means they are giving you a hint about two forces about the point A. At this point A, two forces are acting. This force is acting. At the same time here also this point B also acting. Since both are going to rotate in the same clockwise direction and have the same force, we can add force into either force into perpendicular distance. Either force means 10 Newton. 10 into perpendicular distance is 0.5. So we will get 10 into 0.5 is 5 Newton meter clockwise. The same way torque about to be here. Again torque into force, either force into perpendicular distance. Same one, because 0 is at the midpoint, same distance. So you can write 10 into 0.5. You will get the answer 5 Newton meter clockwise. Now the third question is calculate the resultant moment of force of two forces about the point O situated exactly at the middle of the two forces. So here we are going to calculate it separately. How much force will be acting at this center, exactly at the center. This case we have to write force into this distance, again force into this distance. Since we are going to calculate the torque about the point O. So force 10 Newton into half of 0.5 is 0.25. Again second one is, since both are having clockwise, we have to add it. So again 10 into 0.25. Now when you add it, you will get the answer 5 Newton meter clockwise. Number 7. A steering wheel of diameter 0.5 meter is rotated anti-clockwise by applying two forces, each of magnitude 5 Newton. Draw a diagram to show the application of force and calculate the moment of force applied. You are asked to draw the diagram. So it's a steering wheel of diameter 0.5 meter and it is about to turn anti-clockwise. So you have to place this arrow downward. Then only the steering will rotate anti-clockwise. And both forces are given 5 Newton. You are asked to calculate the torque. So since it is at the center and both are same force, we can use either force into distance. Coupled force, we are acting coupled, two equal and opposite forces acting in the opposite direction. So force into distance, either force 5 into 0.5, you will get the answer 2.5 Newton meter. Next question number 8. So up to this question number 7 we are simply finding torque or moment of force is force into distance. Now question number 8 onwards we are going to the second stage of problems. Here we are going to consider a meter ruler, that is a normal scale. Uniform meter ruler, if in the question it is given uniform meter ruler, means it is understood it is a meter ruler with 100 centimeter. And you should know for every object the center, since it is a meter ruler, it is a rod, the center of gravity is at the center of the ruler, that is at 50th centimeter. So these are the two basic concepts you should know when you start doing the problems related to uniform meter ruler. Okay, so here question number 8, a uniform meter ruler. So when you read that point, read that sentence, uniform meter ruler, the same day you have to draw a straight line, mark 0 centimeter, 100 centimeter, and you just mark 50 centimeter at the middle. A uniform meter ruler is pivoted at its midpoint. So you can draw pivot, that is, it's a pivoting at a set midpoint. Midpoint means 50 centimeter. A weight of 50 gram force is suspended at one end of it. They are not specifying which end. So any side you can hang a weight of 50 gram force. So automatically what will happen when we place a uniform meter? I think you know how to measure the weight using a beam balance. So you just imagine you are using a beam balance, pivoted at the center, and in one pan we are placing a weight of 50 gram force. So basically what will happen? This side tends to come down. Okay, it will have an anti-clockwise moment. So our question is, we are provided with a 100 gram, a particular weight, force is given 100 gram. We have to find at what distance we have to tie it so that the ruler will become again horizontal. So we are going to apply the principle of moment. Sum of clockwise moments is equal to sum of anti-clockwise moment. So this side clockwise moment or anti-clockwise, this side moment is force into distance. Force, here it is our weight 50 gram force and distance is 50 centimeter. Other side force is 100, distance we don't know. So we are asked to find where we have to hang it. So 50 into 50 is equal to 100 into distance. Now these two zeros and two zeros cancel. So we will get distance is equal to 25 centimeter. So in the textbook you can see the answer is written at a distance 25 centimeter from the other end. Or generally not without any confusion you can write at a distance 25 centimeter from the center. It will be easy for you when you are finding a particular distance. We are finding the distance from the center. So either you can write like this, or better as a safe side you can write, we can hang this weight at a distance 25 centimeter from the pivoted point. Okay, both answer will be correct. Next question number 9. Again a uniform meter ruler. So if it is written uniform meter ruler, just draw a straight line, mark 0 centimeter, 50 centimeter, 100 centimeter. This is the basic structure. 0, 50, 100. Here it is given, it is pivoted or balance is horizontally. Ruler balances horizontally on a knife edge. Another name of pivot is knife edge. Knife edge placed at 58 centimeter. So here the ruler is balancing at 58 centimeter. When a weight of 20 gram force is suspended from one end. So first of all we can consider this without considering the 20 gram force. You should know, if we are balancing the weight at 58 centimeter, that means length of the scale in this side will be more compared to this one. This is the longer arm and this is the shorter arm. So to which side the scale tends to rotate? Obviously the longer side will have more mass, so it will try to come downward this side, that is anti-clockwise. So here they are saying to make the beam horizontal, since the ruler is trying to move downward, they are going to place they already placed a weight of 20 gram force at one end. They are not specifying which end, but we should use the common sense to make the beam horizontal. Still the object is moving downward, we should know the weight should be hang at 20 gram force at the other end, that is 100 centimeter. Already this side is longer. Again, if you are placing 20 gram force here, again what will happen? It will move downward. So to balance this length, we have to place the 20 gram force at 100 centimeter. So they will not specify where to hang it, but we have to find which will be the position, which end is that one end. Now we got it is 20 gram force. Now here they are giving how 58 mark when the draw a diagram for the arrangement. What is the weight of the ruler? Here we are asked to find the weight of our scale or our meter ruler. As I already told, the weight of all the objects will be at the center. So we have to mark center at 50 centimeter. What will be the weight? So force into distance is equal to force into distance. Force, that is our weight into distance. 50 to 58, that means this distance is 8, is equal to 20, that is force. Distance 58 to 100, that is 42. While calculating, we will get the force, that is weight of the scale or meter ruler is 105 gram force. Next, question number 10. Already the question diagram is given in the textbook. Clear picture is there. Here we can say again it is a uniform meter ruler. Pivot at the center 0. To this side 50 centimeter, this side 50 centimeter. That means it is a uniform meter ruler. And towards the left side you can see at the 40th centimeter. That means from 0 they are calculating. Since it is clearly given in the diagram, you can see it is clearly given in the diagram. From 0, 10, 20, 30 and towards left also, right also 20, 20. So at the 40th centimeter it is 40 gram force is suspended and they are provided with 80 gram force and they are asking where should we suspend to make the ruler horizontal. Simple, just multiply force into distance is equal force into distance. 40 into this length is 40 is equal to this length we don't know, force is 80. So 40 into 40 is equal to 80 into distance. Then from here we will get distance is 20 centimeter. So we have to write, we have to hang or the object should be placed at a distance 20 centimeter from the center. Okay, 20 centimeter from the center. Next, question number 11. In question number 11 also, the diagram is clearly given in the textbook. Here also it is a uniform meter ruler, 0 centimeter. At the 10th centimeter, a weight of 40 gram force is hung and it is pivoted at the correct middle 50 centimeter. And again at the 90th centimeter, again a mass of 20 gram force is hung. And here is the last point 100 centimeter. Our question is already length is given, both side length and both side force is given. We have to find whether the ruler is kept horizontal or not. So according to the principle of moments, if sum of clockwise is equal to sum of anti-clockwise, then only the ruler will be horizontal. So we are going to check whether the ruler is horizontal. Force into distance equal force into distance. Force 40 into distance is 40. 40 into 40 equals, here the force is 20 and the distance 50 to 90 it is 40. So we got 1600. That is towards anti-clockwise moment is 1600 and the clockwise is only 800. Okay, so is the ruler in horizontal way equilibrium? No. We have to say no. So to which side the meter ruler will tilt? Which side have more force? This side. So it will tilt towards anti-clockwise. So automatically the scale starts to bend downward to this side. This side bending downward means it is having anti-clockwise moment. Now they are providing, since it is moving downward, we can apply some force on the opposite side to make the ruler horizontal again. For that they are giving an extra force of mass of 40. 40 gram force is given. Our question is, where should we hang it so that already the scale is trying to move downward. To bring it backward, where should we hang the extra mass? So force into distance is equal to, here this side, again the third step of problem, one side itself two forces are given. So F1 D1, that is our first one. F1 is 40, D1 is 20. plus F2 D2. F2 means 40, second force. D2, where should we hang? It is not known. We have to find it. So 1600 is equal to 800 plus 40 D2. Here 40 is our second weight. So what will be D2? D2 is equal to 1600 minus 800 by 40. You will get 20 centimeter. That means we should hang the extra mass of 40 gram force at a distance 20 centimeter from the center. From the center 20 centimeter means after 20 centimeter, that is at the 70th centimeter mark. So you can write the answer in both ways. Either you can write at the distance 20 centimeter from the pivoted point, or you can write from 50 to 20 to 70 centimeter. So at a distance 70 centimeter on the scale. Next question number 12. When a boy weighing 20 kg sits at one end of a 4 meter long seesaw, it gets depressed at this end. How can it be brought to horizontal position by a man weighing 40 kg? So this is a long seesaw. The length of the seesaw is given 4 meter. So obviously you know the seesaw will be pivoted at the center at the 2 meter. And the boy, we used to sit at the end. The boy is sitting at one end. The weight of the boy is 20 kg. So automatically this side will get depressed. So our question is, another man is coming to make the seesaw horizontal. Where should he sit? The man is weighing more than the boy. So if he sit at the extreme end, again that side will be depressed. So where should the man sit to make the seesaw horizontal? So force into distance equal force into distance. Here force into distance means sum of anti-clockwise is equal to sum of clockwise. So force here is 20, distance is 2 meter. 20 into 2 equals 40 into distance we need to find. So from here we will get distance is 1 meter. That means the man should sit at a distance 1 meter from the center on the opposite side of the boy. Question number 13. Here you can see a physical balance has its arms 60 centimeter and 40 centimeter. Directly they are giving the arms of the physical balance, that 60 centimeter and 40 centimeter. What weight kept on the pan on the longer arm will balance an object 100 gram force kept on the other pan? So directly they are giving one side the mass is given 100 gram. What mass should be kept on the other arm to make the physical balance horizontal? So force into distance equal force into distance. F into 60 equal 40 into 100. F is equal to 4000 by 60. You will get the answer 66.6666. It will go on. So round off to 2 decimal point. You will get the answer 66.67 gram force. Next question number 14. Here question number 14. The diagram is clearly given in the textbook. This is the diagram. The midpoint is given. One length, arm of the one length is given 40. Another is 20. So here the question is, calculate the total anti-clockwise moment. Pivotal point is here 40 centimeter, mass 150. At a distance 20 centimeter, 250. So we had to calculate anti-clockwise moment. So this side will produce anti-clockwise. So force into distance 150 into 40 will get 6000 gram per centimeter. And you have to keep in mind all through this problem we don't want to convert the units. If it is given in centimeter and gram force, let it be that itself. So 6000 gram per centimeter. And second question is calculate the moment of force, clockwise moment of force. So this side is clockwise. Force into distance 250 into 20, you will get 5000 gram per centimeter. And third sub question is, what is the difference of anti-clock and clockwise moment? So simply subtract 6000 minus 5000, you will get 1000 gram force. So obviously you know this side, the depression will be towards this side. So the next question is, they are provided with an extra mass of 100 gram force to make the beam horizontal. So where should we keep this extra mass? Okay, here already this side is depressed because Anti-clockwise moment is 6,000. So this side is more, it will depressed. So you are provided with an additional weight. Where should we keep? So force into displacement is equal to F1 D1 plus F2 D2. So 150 into 40 equal F1 D1. Or directly you can write 6,000 is equal to 5,000 plus second mass 100 into D2. From here D2 is 6,000 minus 5,000 by 100 will get 10 centimeter. So from the center towards 10 centimeter, or you can have 10 centimeter on right side of O. So here somewhere at 10 centimeter we can hang 100 gram force. So the beam again will become horizontal. Next question number 15. Here it is a different method. Here we are going to balance the beam at, or balancing this scale. I am just balancing at one end. So you can see the scale will get depressed towards the other side. Okay. So pivoting is at one side. Pivoting is at 0 centimeter. A uniform meter ruler weight 10 gram force. The weight of the ruler is given. I already told the weight of the object will be at the center. Uniform meter ruler means 100 centimeter. So the weight of the ruler should be at 50 centimeter. So the weight of the ruler is 10 gram force pivoted at its 0 mark. They are specifying pivoting is at 0 mark. What moment of force depress the ruler? So basically the ruler will try to come downward. So this side coming downward is clockwise direction. So moment of force, force into distance. Force means weight of the scale. We are not adding any other force. Only the weight of the scale is given. So force is 10 and the distance. This is the distance from the fulcrum to the weight. So fulcrum or pivoted point. So 10 into 50 will get 500 gram force. And here the second sub question is, how can it be made horizontal by applying the least force? We studied to get least moment of force. We have to apply least force at the extreme end. That means I am going to apply force in this opposite direction. That means when the scale is get depressed, someone should, okay, here the scale is get depressed at one end. We are the pivoted point is at one side. We have to apply force. We have to apply force at the one end in the upward direction. So the question is, what force should be given at the end to make the ruler horizontal? So force into distance equal force into distance. Here this force into distance 10 into 50. This is force, distance is 50. Is equal to second one, force into distance. Here the force we need to find. Distance is 100. We studied in class 6 a principle of levers. Load into load arm equal effort into effort arm, or load arm, effort arm. That is distance from the fulcrum we have to calculate. So 0 to 100. That is why I took here force into 100. From here we got 100 by 10 into 50 will get 5 gram force. So we have to apply 5 gram force in the upward direction to make the horizontal, make the ruler horizontal. Next question number 16. A uniform half meter ruler. Uniform meter ruler is 100 centimeter. Half meter ruler means 50 centimeter. So 50 centimeter basically the center will be at 25 centimeter. A uniform half meter ruler can be balanced at 29 centimeter mark. So pivoted point is at 29 centimeter mark when 20 gram force is hung from its one end. So here again they are not specifying which side we are going to hang this 20 gram. So basically you can see this is the longer arm. So the longer arm tries to move downward. So to make the ruler horizontal, we have to place the weight at the 50th centimeter. You are asked to calculate the weight of the ruler. Weight will be always at the center. So force into distance. Force we need to find. Distance is this small distance, that is 4 centimeter is equal to 20. This is the weight. Force into this distance is 21. So from that we will get force is equal to, or weight of the ruler is 105 gram. Next question number 17. Our last question from this chapter. A uniform meter ruler, again it is a uniform meter ruler of mass 100 gram. Mass of the ruler is given 100 gram. Since it is a uniform meter ruler, weight will be at 50th centimeter. So they will not specify where is the mass. You should know mass of the object will be at the center. So at 50th centimeter, 100 gram is balanced on a fulcrum at 40 centimeter. So pivoted point or fulcrum is at 40 centimeter by suspending an unknown mass at 20 centimeter. At 20 centimeter, a particular mass is hanged. Find the value of m. We have to find m. So force into distance equal force into distance. Here force we don't know. Distance is 20. Here force is 100. Distance is 10. So F into 20 equal 100 into 10. You will get F is equal to 50 gram. So the mass, we got the unknown mass as 50 gram. Now here they are saying in this position now it will be in equilibrium. That is here if it is 50. 50 into 10 is 500. 100 into 10 both sides it will be 50 into 20. 50 into 20 and 100 into 20 both will be the ruler will be in the horizontal position. Sum of clockwise is equal to sum of anti-clockwise. Now they are saying instead of this 20 centimeter, if we are pulling this mass to 10 centimeter, okay, I am just changing. So you have to draw the second diagram. Pulling this mass to 10 centimeter, what will be the resultant moment? So what we have to do? Again we have to find the sum of clockwise is equal to sum of anti-clockwise. Here the question is, to which side the ruler will tilt if the mass m is moved towards 10 centimeter. So if you are moving this side, to which side it will tilt? It will tilt to anti-clockwise towards the 10 centimeter. What is the resultant moment? So again we have to find the resultant moment. Here what will be the resultant moment? The weight is 50, distance is from 10 to 40, that is 30. So 50 into 30 is equal 10 into 100, that is 1,500. This side will be 1,500 and this side is 1,000. So this side will be more, 1,500 and 1,000. Anti-clockwise, anti-clockwise is 1,500 and clockwise is 1,000. So what will be resultant? Just subtract 1,500 minus 1,000. You will get 500 gram force anti-clockwise. Okay. So now there is a depression towards this side. So again they are giving an extra mass of 50 gram to make the depression again horizontal. So where should we hang this mass? So force into displacement, F into D is equal here F1 D1 plus F2 D2. So force into displacement 50 into 30 equals 10 into 100 plus 50 into D2. We don't know where should hang this mass. So while calculating, we will get D is equal to 10 centimeter. So you have to write the proper sentence by suspending a mass of 50 gram at the 50th centimeter mark, or 10 centimeter means from the fulcrum 10 centimeter. Fulcrum is at 40th centimeter. From 40 to 10 means 50th centimeter. So you can write either from the center, from the fulcrum towards the right side 10 centimeter, or you can write at the 50th centimeter mark we can hang the extra mass to make the ruler horizontal. Thank you.